All right, what I want to talk to you about is assignment A8. I posted a solution, and the solution looks a little bit on the scary side. And the reason that it does is because I added a bunch of things in there to address code that folks wrote. They decided to use a selection sort, or they decided to modify the bubble sort to make it work a little bit more efficiently, or what have you. So what I'm going to do is go through this code very briefly so that you understand what I was doing with these various functions, and that you understand that there are certain functions that are in the code that aren't actually being used and that you do not have to implement in order to be able to make it through this class. So what exactly did we have to do? We had to collect some names and some salaries. And we had to stick those names and salaries into arrays, like so. One of the questions that came up while people were writing this code was, how do I link the names with the salaries? Well, if you look in your book, you'll find that the way that we do that is by using the same subscript. For example, let's say that we have an array called n, and we say that it will hold our names. Array n holds our names. So let's say that array position 0 is going to hold the name Dave. And that array position 1 is going to hold the name Tom. If we have a salary associated with Dave and associated with Tom, there are a couple of ways of handling this. We can either use what are called multidimensional arrays, which can be kind of confusing, or we can create what's called a parallel array. And I'm going to use S for salary. So what I would do for Dave's salary, in the array S, position 0, I would store Dave's salary of $23,000. And if I wanted to store Tom's salary in array S, position 1, I would store, say, $26,000. So what is it that links these two together? What is it that makes it so that Dave is linked to the $23,000? It's this critter right here. It's a subscript, all right? If we always use the same subscript, then the data that's related to the subscript would all be, for lack of a better way of saying it, related. Anything, and I'll just put a question mark for the variable name, anything sub-0 is going to be related. So that's a huge principle. That means if I'm going to make a change to Dave, okay, I'm going to write a function, change. If I'm going to make a change to Dave, and I'll just say n for the array that's coming in, I will also have to include the other arrays. And when I make the change, I'm going to say n sub I is going to be equal to, say, the new whatever. That's an n there. And s sub I is going to be equal to the new whatever. You'll notice that I is the same. And you could, if you wanted to, I suppose you could pass in I right there. In fact, let's just make a little bit of room here. We'll go ahead and comma I, like so. And now we have the arrays themselves. We have the index of where the element within the array resides. Now you'll notice in Python there is no clue as to what this actually is. Is this an array? Is this just simply a variable? Is it a floating point number? Is it a string? What exactly is it? Well, we don't really know, but Python does. If I type in n and I use a subscript on it like so, Python is going to look at that as though it's an array, and it's going to try to act on it. And if it turns out that n isn't an array, it's going to go ahead and crash. So having said all of that, let's go ahead and just take a look at our code, what we did here. Up here, I declared names. So names is going to hold the names of my individuals, and then salary is going to hold the salaries of my individuals. The next thing that I did was I collected user input. So literally, you guys, when I wrote this code, when I wrote this program, I wrote it exactly this way. I wrote down names equals this, salary equals this, and then I said populate arrays, names, and salaries. In truth, at the moment I wrote this little line of code, this function right here did not exist. It wasn't there. I put a little to-do message, TODO, make function, so that I would remember to go back and actually write the code that will be necessary to populate these arrays. So then the next thing that occurred to me while I was writing my little program is, you know what? While I am debugging this thing, making sure that all of this works, it's going to be a nuisance to have to input data every single time that I try to look for a new problem. So what I'm going to do is I'm going to make it so that if the length of names right here, if that critter is less than 2, which means if it only has one name or it doesn't have any names at all in it, then I'm going to print a message that says that the sort cannot be accomplished on less than 2 elements, and then I'm going to say populating the arrays with test data. And I'm going to call 2 new functions, one which populates names, this guy up here, with data, and populates the salaries with data. Hopefully that makes sense. That means I have to come up with another to-do, TODO, DEF, define functions, that one, and that one. Once I've collected the information and my arrays are populated, the first order of business that I need to do is I have to print them out as unsorted. So I created a function called print names and salaries, where it accepts the names array and accepts the salaries array, and it accepts a message that says unsorted. And I've stuck that in a variable called header, which you guys are going to see how all that works in a second, because I'm going to show you every single one of these functions, okay? So then, after I printed it all out, I went through and I sorted them. Now you'll notice that this comment that you see right here is rather large. And the reason that it's so large is because this line right here is the actual comment. This line here is a line of code that if I uncomment it, if I get rid of that, it's going to execute a function that's called sort data by salaries BF, which means brute force. If I uncomment this one, it's going to come back here and it's going to execute a function called alternate sort by salaries BF, again, which means brute force. So I wrote 2 functions right here, these critters, this one right here and this one right here, these 2 functions that would accomplish a brute force bubble sort of the data using 2 different methods. One of them I used a for, and the other one I used a while, because that's what people handed in. Some people handed in a for loop, and some people handed in a while loop, and I wanted you guys to have examples of what they were. And then I created another function called sort parallel arrays using another technique which we'll discuss. And then finally, I created yet another function, sort data by salaries. This function sorts parallel arrays, and what this function does here is using what's called a selection sort, so that you can see how that works code-wise. And then down here, I'm just sorting data by salaries, and I'm not using the brute force method. We'll talk about what that is in a second. And then finally, though, after I've accomplished the actual processing, then what I want to do is I want to once again print the names array and the salaries array so that we can see that they were sorted, but this time I'm going to change the heading text. And then it'll be done. Of course, this little line of code right here executes all of this stuff over here, right? All of the main. Hopefully that's making sense. So let's go ahead and take a minute and let's look at populate arrays, names, and salaries. Here is my populate arrays function, and as you see, I created comments. It basically says that this function prompts for and obtains names and salaries from the user. If the user enters an asterisk, the input loop will stop, which means we're using a sentinel. Parameter n is the name array by reference. When we call this thing, we will call it literally by saying populate array, and in this position we'll say names, and in this position we'll say salaries, or some people used earnings or something like that. Parameter s is the salary array by reference. And what I mean by saying by reference is it means that arrays, when they come into a function, they are not copied into this function. What happens is Python keeps track of exactly where the array is in memory, so that rather than copying the critter, they're going to actually perform whatever action we want directly on the original array. So we're making a reference to where the array originally was placed in memory so that we can work on that same array. So basically we're working on the same array. We're not working on a copy. This is something that's kind of important to realize. So we prompt the user with a message that says, please enter the names and salaries, and then to finish entering the names and salaries, enter an asterisk, and you'll see that I have a backslash quote, which means escape the quote so that it can be printed, as opposed to thinking that it was one of those kinds of quotes. While name is not equal to asterisk right there, what I want to do is get the name. I created a function called getName, and my function accepts a parameter. My name accepts a parameter, and that parameter is the prompt to the user. So a message is presented to the user, please enter the employee name, and the little brackets there that says star to finish. So the user answers that, some value goes into name, and if the value isn't a star, then it's going to get the salary. Otherwise, if it is a star, what's the point of getting the salary, right? We don't want the name in there. There's no point in getting the salary. If we do succeed in getting the salary, then what I'm going to do is I am going to take whatever is in the variable name right there, and I'm going to append it to my name array. And whatever is in the variable salary, I'm going to append it to the salary array. Let's assume that this gets run for the very first time. That means that the index of the array is at 0. N sub 0 and S sub 0 are expecting some kind of data. So you can see right away that these two pieces of data are related. They're linked together because we're dealing with what is called a parallel array. So let's take a minute and let's go back and let's have a look at getting this salary, the salary function, and the name function. When I wrote my input function for getting the data in there, I used two other functions. One was getFloat, and the other one was getName. The reason that I did that was because it's really important to try to make your functions do only one job. So the function that's calling these two functions does the job of simply getting information. These two functions here, though, do the job of getting a name and getting a floating point data. There isn't too much to it. The name one, I don't remember if I shared that with you before. I'm pretty sure that I did. Is really easy. All it is input prompt. Some people would argue that it's kind of a waste to do that. You just, created 2 lines of code when I could have just taken this one single line and simply put it into the function that called this function. This keeps everything nice and organized. If I want to, later on down the line, make a change on how my program responds or presents things to the user, such as creating a box for getting input, or changing the color to some other color inside the box, or putting double borders around it, or whatever, I could implement all of that very easily because I took the time to create this function. Now, in the case of getting a floating point number, well, this is a little more of an issue, isn't it? Because as you recall, what we do whenever we get input from Python, we will receive a string. And we're hoping that that string will contain string versions of numbers. For example, if I had the number 19, then what would actually go into my computer would be the number 31 hexadecimal and 39 hexadecimal, which are not at all the number 19, right? So we have to cast that using a float cast in order to be able to turn it into an actual number. So that's what we do. We try to turn S, the number that we tried to input, and by the way, that's not S, it's supposed to be num. I thought I fixed that and I didn't. We're supposed to turn this into a floating point number. So we come down here, and sure enough, I actually did achieve, using num like I was supposed to. So we turn this thing into a floating point number. If it can turn into a floating point number, then we were successful. We're going to just return the floating point number. Now, some folks would say that you shouldn't return in the middle of a block. You should wait down here to do a return. You should take this and store it in a data variable. I'm of the mind that, sure, that's a reasonable thing. Fact is, that's what I usually do myself. But because so many other people do not do that, I wanted to provide you with an example where people literally return from inside an existing block of code. And in this case, it's the try block. So they're returning from the try block. But what if it fails? What if it just crashes? Boom, 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 boom. Well, what it's going to do is it's going to cause the computer to issue an exception because we violated one of their rules. And it's going to come into this little block of code. It's called except. Other programming languages will call this catch. We put in a little remark to ourselves to remember why we did this, and it says the float cast failed. It means we tried to cast it to a float and it crashed. So we want to message the user and try it again. So how is it that we're able to try it again? Well, it tries it again by virtue of the fact that we never made it to the return. So it'll go through here, it prints the message, and then it falls out of here, and since all of this stuff is still in the while loop, it comes right back up to the top of it. And it continues doing this little job until finally we have a valid float number. Now, other people, what they'll do is in get float, they'll say done equals false. And the while will be while not done. Do all of this stuff. And rather than return float name here, what we will do is we'll say done is equal to true. And we'll make sure that some value is going to be equal to the float number. Hopefully that makes sense. So that's the input. So then what happens if the user inputs a star right off the bat? Well, it means that we don't have any data that can be sorted. We run into a problem. So either you can message the user saying, hey, please enter some data, or we can use that for entering test data. And if you look at your listing of the program, you'll see that I actually check to see, is the array length less than 2? If the array length is less than 2, then call two functions. And one function is populate the test names over here, where literally I return an array of names right there. And the next function that gets called is populate the test salaries, and it literally returns these salaries. Because Albert was the first name in the array, Albert gets this salary. Andy then gets this salary, Bill gets this one, Carl gets this one, David gets this one, Edward gets that, and so on and so forth. All because this is subscript 0, 1, 2, 3, 4, 5, 6, 7, and 8. And so it is up here 0, 1, 2, 3, 4, 5, 6, 7, and 8. These arrays have exactly the same length. And this is really, really, really important that they are equal. If they're not equal, I probably should write a little piece of code that causes me to jump out of the program or send a message to the user that things have gone wrong or whatever later on. And in fact, I did do that, and I'll show that to you in a minute. So at any rate, that's how we handle populating the test data into our arrays. Once we get the data into the arrays, then the next step is to print the names and the salaries for all the people using a particular format. So what I did here was I created a function that does exactly that. It prints names and it prints salaries, and it also includes a little heading. So the first thing that I did was just simply a print, and what that resulted in was a line feed. So if this is my screen, I just now printed a line feed or a blank line. And then the next thing that it's going to do is it's going to print whatever was passed into heading. It might be unsorted, it might be sorted, but heading like so. And then finally down here, I said for I in range, the length of n. So what is n? It's my names. What is s? It's my salary. I know that n and s have exactly the same length. So if I find out what the length of the n array is, then all I have to do is just start working my way through that array. So exactly what happens? We know that range length n is going to produce the numbers 0 through whatever the length of the array is. In the case of my test data, it is going to be 0 through 7. Because remember, it doesn't do the very last one. How do I handle all of that with respect to what's going on inside this loop? I took advantage of what are called format codes. I said print 15s, or %15s, and Python looks at this %15 and it says, oh, I need 15 spaces, 1, 2, 3, 4, 5 through 15. I need 15 spaces, and since it's the letter S, it's going to be character data, or some people would call it string data. And then I'm going to finish up at the end of that string data, I'm going to put a colon. And then next thing we do is we put in a $sign. We're just going to print a $sign. I could print F, I could print C, I could print the pound symbol for British currency. Whatever I wanted to print there, I could print it. Then the next thing you see is the %, which again, it is a key symbol for formatting information. And we see the number 8. And the 8 says that I have to reserve 8 total spaces, 1, 2, 3, 4, 5, 6, 7, 8. And then I need to make sure that it has 2 points of precision. So I'm going to put my decimal point right there. I can handle a number that is 6 integer digits in size and 2 fractional digits in size. Now that I've done that, we have right here one input into this string, one formatted input. We also have a second formatted input. That means that we better have 2 variables. So in Python, we use the % symbol again, and then in parentheses, we create our list of variables. And you'll notice that we have our names and we have our salary. And since I is working its way 0, 1, 2, 3 through 8, then when I is at a 0, it's going to print out n sub 0, and s sub 0. When I is at 2 or whatever, or even 8, is going to print out, I'm sorry, not 8, 7, is going to print out n sub 7 and s sub 7, okay, as it works up, and it's going to create a nice kind of a tabular format. So that's how we're going to be getting our output. So we print what we currently have, and then we know that we're going to be calling this again, which exposes another rule of thumb, and that is, if you're going to do the same activity more than one time, write a function. And so that's what we did right here. Okay, now we have the first of several different swap routines that we have. Several different sorting routines that we have for bubble sorting or selection sorting our data. So right now I have a function that's called sort data by salaries, BF, which stands for brute force. Well, what exactly does that mean? Well, that means that if I have, say, 1, 2, 3, 4, 5, 6, 7, 8, and let's say that I have whatever numbers, and let's say that the number right here is 8, and every other single number that's in this list is less than this number here. That means that every time it goes through, 8's going to get moved to this position, and then to this position, and then to this position, and so on and so forth, and it's going to bubble or trickle its way on up until it finally lands into that position there. And it's going to do it by swapping the contents of where it currently is and this cell adjacent to it. What exactly does this mean to us? If we bubble the largest number that we have available to us in the last position, we don't necessarily have to do what's called a brute force method, because what a brute force method is going to do is it's going to compare those two cells, then these two, then these two, then these two, these two, these two, and those two, and whichever one comes up on top is going to advance the bigger one into the next cell, which means that we end up comparing these cell pairs every single time. That's the brute force method, and that's what you're seeing here. We see that every single time we end up doing a comparison. Here, we realize that this is holding the maximum number. The first time it goes through the loop, the maximum number is in this position, okay, that you see right here, this position. It will never swap again. So there is no point in the inner loop going to the trouble of reaching to the end of the array. So in other words, the inner loop, the first time through, is going to go through 7 times. The second time through, though, is going to go through 6 times. So it's going to be the length of n minus 1. The next time through, it'll be the length of n minus 2. The next time through, it'll be the length of n minus 3, and so on and so forth, because every time the outer loop happens, this critter right here, every time the whole thing happens, we know that the next largest number ended up in the next cell. I'm hoping that that kind of makes sense to you. If it doesn't, no big deal. Because this program is small enough, we can use just the brute force method, and that's what we're looking at right here. We have our name array, we have our salary array. For I in range of length of name array, and we're going to start the index with 1 because j minus 1 equals 0. So here we have 1, which is right there, and right here we have 0. If s in position 1 is less than s that's in position 0, then we're going to do what's called a parallel swap. We're going to pass in both of our arrays. We're going to pass in the positions of our indexes so that our little program right here, or rather our little function, will be able to perform the swap for us. Notice when I wrote this function, I didn't really concern myself with how this swap was going to even happen. I didn't care about that. I only know that I wanted to swap it and that I was going to be working on parallel arrays. So I wrote a function, or I wrote a command line right here that just simply says swap parallel, that I knew would need the name array and the salary array and 2 indices. But I didn't write the functions yet. So now it's time to go and write those functions so that they will work. Here we have our function swap parallel arrays. Here's my name array, Here's my salary array. Here are my two indices. And you'll notice that it says swap the name array data. And then I call another function that says swap array elements. And then down here it says swap the salary array data right there. And then it calls the same function again. Well, not really the same function. It could call the same function. What I did for you guys is I created two functions that will swap the elements of an array. One of them uses the traditional method, and the other one uses the Python method. And we're going to go ahead and take a quick peek at what those are right now. Looking at the traditional method, a lot of computer programs will only allow us to do swaps of data using this method. Because we can have a box here. Let's say we have a box that's holding some data here. We'll call this box A. And we have a box here that's holding some data called box B. So let's say that A has 10 in it and B has 25 in it. And let's say that I want to swap the data. Well, the moment you copy the data from B into A is now going to have 25 in it, and the 10 gets lost. So we want to avoid losing that information. And the way that we do that is we take and store whatever is in a temporary position, which I call T. So we have our array, and it doesn't care what array it is. It only cares that if there is an array, that we have one index location in the array, and we have a second index location in the array. It's going to take whatever is in A sub, let's say that it's A sub 0, okay? It's going to take whatever is in A sub 0 and it's going to stick it in T. And then it's going to take whatever is in A sub, since J is 1 now, it's going to take whatever is in A sub 1 and it's going to put it into A sub 0. And then it's going to take whatever is in T and it's going to put it into A sub 1. So now let's take a look at the other method. And this is the Python method. With Python, it doesn't care if we use a temporary variable or not. We can literally take and do multiple assignments, or parallel assignments as it's called. What I am doing at the same time, I'm going to take whatever is in A sub j and I'm going to stick it in A sub I. And as I said, at the same time, it's going to take whatever is in A sub I and it's going to stick it into A sub j. Now, there aren't very many languages that will do this. Python will do this, Ruby will do this, and a couple of other scripting languages, but Java will not do this. Nope. The C programming language will not do this. JavaScript will not do this. And C++, C# as well, so C++, there we go. None of these languages will execute that line of code. So what we've done here is we've taken advantage of a cool feature in Python that will allow us to do a convenient swap. If I feel really, really ambitious, I will post another video that provides a lot more detail on how swaps work, but hopefully this makes sense to you. Here we have a function example that I have provided that you don't necessarily have to use, but it is slightly more efficient than the brute force bubble sort method. This takes into account that values, once a value is bubbled to the end of the array, whether it's the least significant portion or the most significant portion, that is, least significant would be element 0 and most significant would be element maximum, whatever the length of the array is. Whether we're bubbling towards the least significant or towards the most significant element of the array, this here will eliminate the use of an element once it is populated with the largest value. And how did I accomplish that? Really, really easy. So we had length minus 1 is the range that I'm dealing with. Here I could have used length minus 1, in which case it would have been a brute force method. But what I did was I referenced the current length of my outer loop. So I'm starting out with the big number, 7 in this case, because that's over, actually the length of the array is 8. I'm starting out with 8, so I for right now goes ahead and does a swap up through cell 7 because of the nature of the range command. So once we go through it one time though, I is no longer this, 8. I becomes 7. So now we will only do the inner loop up through cell 6, and so on and so forth. Every time the outer loop executes, then the range of the inner loop decreases by a little bit. So here's another method for being able to do the sort, and you'll see once again I'm using swap parallel. So I'm not rewriting that code and sticking it into this portion. Once you write swap parallel, you're done writing it. You don't have to worry about it anymore. Here is an alternative bubble sort. Alternative bubble sort, but instead of using range or for loops, we are now going to use a while loop. Here we have length is equal to length minus 1. We've set up a flag, the loop control variable, and notice again, everybody, how much I've commented this thing. I commented it a little heavier than I needed to make sure that you guys understood it. Here we come down through here. We have while not done. Done is equal to true. I'm going to go ahead and set it to true right off the bat. And you'll notice that I stuck a little semicolon behind these. What this is a mistake. I am so used to programming in other programming languages that require semicolons that sometimes one sneaks in there. And the reason that I left it in this code example was so that you know Python forgives semicolons in most cases, because it knows that a lot of people that are coming into Python to write code are coming from a C-based language that requires semicolons at the end of their statements. I immediately set done to true. I'm going to assume that I only need to do this one time. Then down here for I in range, length, which length was what? Length was this thing right up here. So we have the length, I in range length, and then if the adjacent cells are out of order, swap them. And then I'm going to keep on doing this until the whole critter is done. Alrighty, this is the last sorting function that I created as an example in this program. And you can, as I said before, use any one of these sorting functions to get the job done. But this one's using what's called a selection sort instead of a bubble sort. And the selection sort you can find on page 510 of the text that we were using in spring of 2016. We may be using it next semester, I'm not sure. You'll notice that things look a little bit different because what I'm doing is I'm introducing some additional characteristics of Python. You'll notice that rather than just simply putting in N for the name array, or in this case, this S for the salary array, and N for the name array over here, I created different variable names. I created a variable name called the key array, and I added a colon, and then right after the colon, I listed the type of data that this is expecting. The key array, key underscore array, it is expecting to be an array. Now, the thing that's cool about this is if it's not an array, the moment I try to execute this, before it actually goes to the microprocessor to begin execution, the Python interpreter will flag this if this isn't an array. If I input a string variable or I input a single number, I will get a message saying, hey, what's up? This is not going to work. So I'm taking advantage of one of the things in Python that will do automatic type checking for me to make sure that I am inputting the correct data into my function. This is a gimme. This is something that you are not going to be tested on because this is kind of a semi-advanced characteristic of Python, but I thought some of you might want to know about that because one or two of you who have actually been using this syntax, and when I asked you if you knew what it meant, only one of the two of you knew what it meant. You grabbed it off the web and said, hey, you know what, Python's requiring me to implement this way, so I'm just going to go with it. I put in the remarks a reminder of what this is all about. I have a parameter called key array that it is Python notation for a array to be sorted in ascending order, that the syntax is the variable name, then a colon, and then the variable type. So what do I mean by key array and parallel array? Well, the key array, whatever is in here first, whatever is in this position, that's what this little routine is going to look at to determine what should be sorted. The fact is, in the other functions, if you accidentally reversed the name list and the salary list, then it wouldn't have sorted on the salary, it would have sorted on the names. So when it comes in first, it becomes the key. The key is what determines how it's going to be sorted. And we have here the key array that needs to be sorted, and here we have the parallel array that's basically going to be kept in sync with any sorting activity that happens on the main array or the key array. And by using the term key array, we're kind of sticking with naming concepts that they use in computer programming. The very first thing I do here is I use what's called an assert. Assert is a command that says if this critter returns false, crash out of the program. Bleed all over my screen. I don't want this thing to move forward unless both of these arrays are the same size. And by asserting that they're the same size, when my program does crash, I will know exactly why. I told this thing that if this isn't the same size, crash the program. I'm running the program and it decides to crash, I will know exactly that the reason it failed was because my key array and my parallel array were not the same size. Or in other words, my name array and my salary arrays were different sizes. So that's what this is all about. So down here I said n is equal to the length of the key array, and then now I'm doing all of the sort stuff again, except for I am now using selection sort techniques, which is much, much faster. For more details on how to do a selection sort, refer to page 510 of your text. So finally, we're back to the main. So let's go ahead and review what's happening line by line just a little bit so that you can wrap your head around it. First of all, because we defined a function main, Python went ahead and it saved all this information to refer to a little bit later on because it knew that somebody was going to be typing in main, open paren, close parenthesis. So down here we sure do that, right? So we type in main, it executes it, and the first thing it does is it defines these variables or declares these two variables. And then down here, it collects the input, right? We're going to populate our array. And if we enter a star, then we're done populating. If the user decides to enter a star right away or puts in only one name, then we're going to look for the length of the names array to see if it's less than 2. And if it is, it's going to tell us that the sort cannot be accomplished with less than 2 elements. It's going to then tell us populating the array with test data. I call my function to populate my names. I call my other function to populate the salaries. I print out the unsorted data. I sort the data using this method, or this method, or this method, or this method, right? And then I print it out again. And then I exit the program. It looked like it was a really, really big program, but I'm sure you realize by looking at the program, you can delete 80% of the code that's there and still get the job done. Hopefully you find this instructive and useful. With that, I'll say happy coding.